Okay, so this is a video explaining the elimination technique in solving simultaneous equations. So if we have two non-parallel straight lines, they're going to intersect at one point. And we can represent this graphically by drawing both lines and then determining the point from the graph. So here I have two straight lines. The first is y is equal to 7x plus 3, so it has a slope 7 and an intercept 3. The second is y is equal to 3x plus 5, so it has a slope 3 and an intercept 5. And the point of intersection here we can see by the blue dot, and we could find that from the graph. We can also calculate it algebraically using simultaneous equations. And here we're going to look at the elimination technique. So here I'm rewriting each of the equations and calling them equation 1 and 2. So I've matched up the y value. I didn't have to do anything here because the number before the y value in both cases was 1. So now when I subtract the second equation from the first, I get a value 4x is equal to 2. I can substitute that in into one of the equations, and I get a y value of 6.5. Here's another example. We want to find the point of intersection between the following two lines. So here I have two equations of straight lines again. We note here now the values before the y are different, so this is slightly more difficult. So again I'll number these equations 1 and 2. And we want to eliminate either the x value or the y value. So I usually choose to eliminate the y value. So to do this I need to match up the y value, so I'm going to multiply the first equation by 7 and the second equation by 4. When I do this I get these two equations, and you see here now the value before the y is 28 in both cases. So when I subtract the second equation from the first, I'm left with 9x is equal to 214. That gives me a value for x of 23.78. I can now find my value for y by substituting this x value into one of the equations. So in this case equation 1, and that gives me a value for y. I can check the two numbers by substituting both of them into equation 2, and we see that it matches up.